Now in this tutorial, I'm going to take a look at a feature in the SpectracyberRPi to fit your data to a curve of your choice. Although primarily the software is used to acquire the data, it does give you the ability to do a little bit of mathematics on your analysis of your data. For deeper analysis, you're recommended to export the data into a CSV file and then run any kind of software you need to do your further study. So let's take a look at curve fitting. Okay, let's take a look at how to do a function fit. First off, in your main application, you click on FunctionFit. We're going to just do one on the temp CSV. It's one of the files we worked at earlier. We, of course, could have picked any file we wanted. And I'm going to take the obvious choice here. We're going to take a Gaussian function. Now, we have a variety of other functions, as you can see, we can choose from. If you choose a polynomial, you can then choose the degree that you want the polynomial for. You can also combine it with a baseline. The baseline will give you a straight line to help try to remove some of a slope if your data is on a rising or falling slope. The type of fit can be a frequency. You can fit it against universal time, the right ascension, or galactic longitude. So we're going to leave it as a frequency fit since I knew this was a frequency scan. And let's go ahead and click the OK button. Now it asks us if we want to check a particular region or if we want to do the entire plot. It's wise sometimes to go ahead and select the region you want, which I'm going to do now with clicking the Yes button, and it'll bring up the graph. And the reason for that is that only a portion of the data is useful to me. So we take our mouse and we can click on one part of this curve because I'm looking for really a Gaussian shape. You see, it'll find a red dot. It'll find the first point that you're closest to. And we'll choose another spot over on the right-hand side. You normally pick your spots from left-hand to right-hand side. This picks a region between, and it's now performed a fit. Interesting thing about this, the fit has performed 23 evaluations. It's used 54 data points between these two mouse clicks. It has 3 variables that it's trying to optimize. It then performs a chi-squared to determine how good the fit is. Of course, chi-squared should be closer to 0. This is not a bad fit, but not the best. It could be better. And then there's a reduced chi-squared, and that should also be 0, pretty close to it. So anyhow, here are our variables. We have an amplitude, we have the sigma, and we have the center frequency of the function. And later on, it'll actually plot what this function looks like. And then, of course, it gives us a best fit. Now, it's optimized. It has done a lot of several calculations, making it best guess at what those parameters, these variables, should be, and it's optimized them after 23 evaluations. So the best fit here means that the curve is someplace about minus 82.5 in frequency with a width of about 77.9. And it tells us what the Doppler frequency would be at that mean point, what the wavelength would be, its wave number, and of course its corrected radial velocity. So now, if we like this curve, we can click the OK button. This is basically a trial and error process. You'll pick the curves until you get satisfied that your chi-squared is good. The curve is automatically saved for you in a particular file location on your working directory. In my case, it's going to be on media and pi in the standard terabyte hard drive that I'm connected to, and it's going to be called tempreport.pdf. So if we click the OK button, it should now produce the figure. Here's the full figure. The red dot shows you the region that is being fitted, and below is another curve showing you the frequency and the smoothed out Gaussian curve in green. So that's basically it. You would do your testing by simply doing multiple curve fits until you're satisfied with your results, and this information can be put into a report. Now what's interesting about this is that this data will show up in a report. Let me click on my file system here. We want to go into where that file was stored, It was stored in the medium underneath Pi on the MyBook terabyte hard drive that I'm using in the SpectraCyber location, and we should see there it is, temp report right here. If we double click on this, it brings up the report. It fills in all the information about your observatory. It then gives you all of the same information you saw earlier. All your Doppler corrections are here. And if we then click to the next page, let's move this up and go on to the next page. On the next page, we have the curve. All this data can be easily put right into your document, your report, or your paper. So there you have it. That is how you can use the curve fit function in SpectracyberRPi. I hope you enjoyed this, and next we'll be taking a look at how to filter some of the data when you have certain noise responses or spurious noises you would like to notch out. There are some special filters that we'll get into later.